Good morning, everyone. Thank you for the invitation from the IEA and Dr. Xiaojing Guo. And I'm Shizong Wang. I worked in the Institute of Nuclear and New Energy Technology in Tsinghua University. It's my pleasure to be here to share our research. Today, I would like to share the topic, electron beam irradiation for wastewater treatment, principle and application. The presentation contains 6 sections. First, I would like to introduce the background of the water pollution in China and the basic and the principles of electron beam irradiation of wastewater treatment. Okay, based on the National Bureau of Statistics of China, in 2021, the total discharge of major pollutants in wastewater is about 253 million tons and determined by chemical oxygen demand. So among the wastewater and industrial wastewater contributed to more than 40% of the total discharge. And the industrial wastewater, such as cooking wastewater, dining wastewater, and petrochemical wastewater, contains large amounts of recalcitrant organic pollutants, such as polyaromatic hydrocarbons, heavy metals. These organic pollutants could cause the potential risk for human and the environment. Unfortunately, the conventional wastewater treatment cannot effectively remove the recalcitrant organic pollutants. So it's necessary to use advanced treatment process for further removing the recalcitrant organic pollutants. To now, the advanced treatment technologies can be mainly classified by 3 methods. The first is a physical-chemical method, such as absorption, calculation, and the membrane process. And second is advanced oxidation processes, such as Findon oxidation and ozone oxidation. And the third one is the combined method. For these methods, they have some limitations in practice. For example, and for the physical-chemical method, the adsorption is widely used in the advanced treatment of cooking wastewater. However, after the treatment of adsorption, the adsorbents has to be further treated. And further advanced oxidation, such as the Findon process, it has a narrow pH application range. Also, if you would like to get good performance using Findon process in practice, usually the high amounts of ferrous ions and hydrogen peroxide are required. So in this case, larger amounts of iron sludge will be produced. That needs to be further treated. Okay, for the combined method, it usually gets the good performance in practice, and the combined method now has been widely used in practice. But the question is that for the combined method, the operation procedure is complex. Also, the treatment cost is high. That cannot be widely accepted by the companies. So it's urgent to develop technically and economically feasible advanced treatment technology. And electron beam technology is an emerging wastewater treatment technology. This picture shows the generation and the characteristics of electron beam. And in general, electronic gun emits the electrons. Under the condition of high voltage, vacuum, and insulation, electrodes in random motion are forced to undergo the directional motion and finally converge to form the electron beam with high energy and high speed. So under the action of the electron beam, the water molecules could be activated to produce several reactive species, such as these hydroxyl radicals, hydrated electron, and hydrogen radicals. This equation shows the yields of the reactive species under the action of electron beam at 100 electrowatt. So here it's noted that for these reactive species, they can react with each other. So during the process of electron beam, there will be a complex transformation relationship between these reactive species. On the other hand, the complex transformation could also provide us a way to regulate the reactive species. So next, I would like to briefly introduce the degradation mechanism of organic pollutants by the electron beam. So usually it includes two ways. One way is the direct action. That means a high energy of electron beam will be directly deposited on the organic pollutants to make them decomposition. And the other way is indirect action. That means the reactive species produced during the process of electron beam can react with the organic pollutants to make them decomposition and mineralization. So our previous studies and the published references have demonstrated that the electron beam can remove lots of recalcitrant organic pollutants, such as pesticides, antibiotics, and chlorinated compounds. So for the electron beam technology, in comparison with the conventional advanced oxidation processes, electron beam can not only produce hydroxyl radicals, but also the reducing reactive species, such as the hydrated electron and hydrogen radicals. Also, it has the direct action. So in addition to organic pollutants, the electron beam could also remove bacteria, virus, and the resistant gene. And based on the work results of our experiment and the actual projects in the last about 20 years, and the electron beam technology has been included in the national standard in China, and this provided a basis for us to popularize the electron beam technology in practice. Okay, the second part, I would like to introduce the research and the development process of electron beam treatment technology. So at the beginning, our research mainly focused on the scientific issues and technological bottlenecks in the treatment of industrial wastewater by electron beam technology. To now, breakthroughs have been made in key technologies and equipment, and forming a core technology system and equipment with independent intellectual property rights for the treatment of industrial wastewater. And this has solved the technical difficulties in the treatment of highly pollutant industrial wastewater in China, and expanded the application fields of nuclear technology. We have obtained the main achievements in the following 4 aspects. The first aspect is the theoretical research. We made lots of theoretical research about the degradation characteristics and the mechanism of organic pollutants by electron beam. And the second, we developed the electron beam based process, wastewater treatment process. And in the third section, and we developed the special equipment for the wastewater treatment. And based on the above 3 aspects, and we use the electron beam technology in practice to treat the actual wastewater. So here I would spend a little bit more time to introduce about the radiation reactor, and that is a key component in the equipment. So it's well known that for the ultraviolet and sunlight, they have the limited penetration in the water. So for the electron beam technology, we have the same problem. If we would like to guaranteeing good performance in the treatment of wastewater, we have to make the water film as thin as possible. So based on the simulation, we use the software to simulate the distribution of energy in the water film, and then we design the special irradiation reactor. Now we can make the water film as thin as 5 nanometer. In this case, we can ensure that the electron beam could completely penetrate the water and to guarantee the good performance. Okay, this picture shows the main sections of this equipment in practice. And in the left picture, this is the control system. And the second picture is shows the coil that's used for increasing the voltage. The third picture shows the electron accelerator. And the fourth picture shows the radiation reactor. And the third part, I would like to introduce the technical characteristics. So electron beam irradiation technology has its own characteristics. First, it's a highly efficient technology. The treatment time is usually shorter than 0.1 second. And the second is a low carbon technology and no demand for chemicals, no secondary pollution. The third is a safety technology. We have developed the special equipment for protection against the radiation. So there is no radiation at all. And the fourth is a reliable technology. And now it's highly the electron beam system has high degree of automation. So we can easily control the whole system just by pressing several buttons on the computer. Also, electron beam technology has its own technical advantages. First, a high processing efficiency, large processing scale, and high degree of automation. For one electron accelerator, now it can treat as much as 5,000 tons per day. The second, it has a strong removal capacity and a wide application range. To now, it has been demonstrated that the electron beam could effectively treat the dining wastewater and the paper making wastewater, chemical wastewater, pharmaceutical wastewater, and so on. And the third, it has a small footprint and a flexible design. For each electron accelerator, it just needs about 200 cubic meter, square meter space. Also, in most of cases, it can combine with the conventional wastewater treatment, such as flocculation and membrane processing. And the last, it has a long service life. And for one electron accelerator, it can serve more than 20 years. And the first part, I would like to introduce the security issues. And when we talk to the people in the factory or the companies, most of them cares about the security issues, especially about the safety of the treated wastewater. So here I would like to introduce the security issues. The safety of irradiation treatment of wastewater mainly involves the following three aspects. The first is the safety of irradiation equipment. The second is the radiation protection program. And the last one is the safety of the treated wastewater. So for the first safety issue, it's safety of the irradiation equipment. For each electron accelerator, it has a reliable method of disabling the acceleration system. That means we could stop the system immediately if we found some problems. And also, we have built in the accelerator and parameter monitoring and remote diagnosis. That means we could control the system online. And from the other side, we also developed the shielding of the electro accelerators. In fact, the radiation devices has been widely used in the disinfection, such as for food disinfection. And now there is a mature experience for references. So based on the above conclusions and the safety of irradiation equipment is not the problem. And the second is the radiation protection problem. So for this safety issue, I think each country has its own this guideline to get people how to operate the electron accelerator. In my opinion, as long as we operate the system based on the guidelines, there would be no problem. So in China, under the radiation dose rate was should be lower than 0.5 microsievert per hour. Okay, the last safety issue is the treated wastewater. Okay, for this issue, we can give these outcomes from two sides. One is that for the common element, such as nitrogen, carbon, oxygen, if we would like to activate them, the energy threshold should be higher than 10 mega electrowatt. In fact, the energy we use in practice ranged from 0.5 and mega electrowatt to 1.5 mega electrowatt. This is far lower than the 10 mega electrowatt. And from the second side, we also monitor the radioactivity of the treated wastewater. Compared to the radioactivity of the background, there was no obvious increase in the radioactivity. So we could see that the treated wastewater is safety. Okay, and the fifth part, I would like to introduce the application of electron beam technology in the treatment of actual wastewater. And our institute collaborated with the CGN Dasheng Electro Accelerator technology to promote our technology in the application, in the environmental application. So to now, we have built more than 10 actual projects, such as dining wastewater, hospital wastewater, and cooking wastewater, and so on. Next, I would like to provide some application cases about the treatment of actual wastewater by electron beam. The first, I would like to introduce the first application of electron beam technology in China. This project was built in 2017. It's located in Zhejiang province. The electron beam technology was used to advancedly treat the textile wastewater. The above flows shows the original treatment wastewater treatment process of the factory. Sorry, I didn't translate in English. Okay, no problem. And for the original treatment process, they use the floccution and ozone oxygen as their advanced treatment processes. The problem is that the influence, the COD, the chemical oxidation, the chemical oxygen demand of effluents was not that stable. That means it fluctuated all the time. So after we checked the original treatment processes, we decided to add the equalization basin after the secondary sedimentation tank, followed by electron beam technology. After is stable below 50 milligram per liter. And the left picture shows the color change before and after the electron beam treatment. Okay, the second application case, I would like to also introduce the treatment of textile wastewater. This project was built in 2020. It's located in Guangdong province. This project was the largest project for textile wastewater treatment in the world, and the treatment capacity of this project is about 30,000 ton per day. And this picture shows the diagram of the electron beam technology unit. We could see that we use the 7 electron accelerator to treat the textile wastewater. And the below picture shows the color change before and after the treatment. And about the original for this factory, the original wastewater treatment use the floccution and RO membrane process as the advanced treatment process. But for these treatment processes, it had two problems. One problem is that the what quantity of effluents was not stable. The second is that the proportion of wastewater reuse was very low. It's lower than 50%. And we upgrade the original treatment processes. We add the electron beam treatment unit after the sedimentation tank. And we didn't change other processes. So after upgrading the treatment processes, the water quality of the effluents was stable. It's below than 50 milligram per liter. Also, the proportion of wastewater reuse increased to 70%. Okay, here there is a obvious advantage of electron beam technology for the treatment of dynamic wastewater. Be different with other advanced oxidation processes. For electron beam technology, the color of the treated wastewater will not be returned after standing for a long time. So this is a obvious technology for electron beam technology. And the relevant date of this project has been published in the Journal of Radiation Physics and Chemistry. If someone is interested in this project, please check this paper. Also, during the application of electron beam in treating the actual wastewater, we found that in some cases, the water quantity of effluents was not that stable because the original wastewater, the quality of the water quality of original wastewater and changed with time. So to solve this problem, we developed this combined processes. That means electron beam technology coupled to Fendon oxidation. As I mentioned above, the conventional Fendon oxidation process has obvious limitations, such as the narrow pH range, application range, and the large amounts iron sludge. But after we use electron beam technology to combine with Fendon processes, we solve this limitation successfully. For the combined processes, the pH range could be expanded from 3 to 3 to 9. Also, during the whole processes, no iron sludge was produced. So this combined processes and provided a solution for the unstable effluents. And the third application case I would like to introduce the antibiotic residue treatment. This project was built in 2021. It's located in Xinjiang in China. This factory uses a biological method to produce antibiotics. After they recover the antibiotics from the water, and the antibiotic residue had to be further treated. And the studies has shown that some antibiotics remained in the antibiotic residue. So we decided to use the electron beam technology to remove the residue antibiotics. Because the antibiotic residue has different properties with wastewater. For example, the antibiotic residue has higher this viscosity than wastewater. So we improved our electron irradiation reactor. This picture shows the improved irradiation reactor. And after the treatment of electron beam, we could see that the sulfin C concentration in the antibiotic residue decreased with the increase of absorbed dose. Also, we conducted experiments to investigate the effect of the electron beam treatment on the removal of antibiotic-resistant bacteria. We could see from the picture. For the first picture, we could clearly see the bacteria colony in the culture dish. But after the treatment of electron beam, there was no bacteria colony in the culture dish. So we could see that the electron beam technology could effectively remove the antibiotic-resistant bacteria. Also, we conducted the experiments to investigate the effect of electron beam treatment on the weight root length. So we could see from the picture, and the root length became longer with the increase of the absorbed dose. Also, we investigated the effect of electron beam treatment on the removal of antibiotic-resistant gene, and the removal efficiency of antibiotic-resistant gene increased with the increase of absorbed dose. Also, the relevant data has been published in the Journal of Cleaner Production. If someone is interested in this project, please check this paper. The first application case, I would like to introduce the hospital wastewater treatment. This project was located in Hubei province in China. It was built in 2021. At that time, the coronavirus outbreaks in China. So the studies had shown that the hospital wastewater contains the coronavirus. So from the point of biological safety, it had to take steps to remove the potential and the virus in the hospital wastewater. So we decided to use the electron beam technology to treat the hospital wastewater. This picture shows the electronic accelerators used in this project. So this picture shows the removal mechanism of the virus by the electron beam, and both direct action and indirect action contribute to the removal of the virus. And the testing results show that in the effluents and the fecal coliforms was much lower than the standard limited. And meanwhile, and the removal efficiency of COD is over 60%. And the relevant data has been published in the Journal of Chemistry. So if someone is interested in this project, please check this paper. In addition to the above for wastewater, we also investigate the treatment of polyacrylamide containing wastewater and pharmaceutical wastewater, antibiotic wastewater. Also the landfill leachate by electron beam technology. The last part, I would like to introduce the application prospect. So now our research and the projects mainly focus on the advanced treatment of wastewater. In fact, the electron beam technology could be also used as pre-treatment processes. For example, electron beam technology can increase the biodegradability of wastewater. In fact, we made some experiments in laboratory, so it really could increase the biodegradability of wastewater. Also, it could be used to kill bacteria or virus, all the bacteria or virus in the sludge. That means the electron beam technology could be used as a sterilization. Now our research mainly focuses on the wastewater. In addition to wastewater, the electron beam technology could also be used to treat the waste gas, such as volatile organic carbons degradation, dioxin degradation. Also the waste solid, such as heavy metals removal and organic pollutants degradation. Also the pathogenic microorganism in activation. Okay, that's all. Thank you for your attention.
Thank you. Thank you, Professor Wang, for the very comprehensive introduction of your research work. We can see that you not only gained a lot of academic achievements, but also application in treating different objects. And now we have time for the participants to raise questions. You can also input your question in the chat box so that we can get your question very clearly, and we can ask Professor Wang to answer them. Or you can, where is the chat box? Please wait a moment. We are waiting for the chat box to show up.
Are you not able to see the chat box, Xiaojin?
Not yet. It's updating.
Okay. There is a question if they can have a copy of the presentation.
Okay, let me share the presentation again then. Can you see the presentation?
Yes, I think they would like to have the whole copy of the presentation. And
Oh.
I believe, are we sharing this in ANENT platform?
Yes, yes. We are sharing this webinar video at the ANENT platform. So please visit the ANENT website to watch the whole video of this presentation. But it will take time for us to create the video and upload it to the platform. So maybe several days. Please, I saw somebody hands up.
Okay. Let me allow this person to be able to unmute. So Nadia, please unmute your microphone and raise your question.
Hello?
Yes, we can hear
Hello,
you.
can you hear me? Yeah.
Yes.
Thank you, Professor Wang, for your informative speech. I want to know how much dose was delivered to the infected water of hospital, which reduced the viruses in 60%.
60% in hospital.
Yes, the infected
Sorry.
water. Yeah.
Sorry, I didn't get the question. Could you please repeat?
Yes. I want to know how much dose was delivered
Okay.
for this procedure.
Okay. Actually, for different objects, we use a different adsorbed dose. The general dose is about 2 kilogram. And for if we would like to kill the virus, I mean more than 90% virus, we use the subdose of 30 kilogram.
Okay, I got it. Thank you.
You're welcome.
Yes.
Yeah. Hi, Xiaojin, Dr. Wang.
Please.
Is there an estimate, for example, how much it would cost to have the e-beam, for example, for the treatment of wastewater in one of the industry, for example, the pharmaceutical?
Okay, I have some data for the price. For the dining wastewater, for the treatment cost is about 2.5 yuan per ton. It's equivalent to 0.4. It's about $0.4 per ton. Per ton. For dining with water. For pharmaceutical water, a little bit higher. It's about 0.6 to 0.8 dollar per ton.
Okay, thank you. It's quite competitive.
Yeah.
So maybe since there's no question yet from the audience, aside from China, do you know which other country had applied this technology at in a commercial commercial situation?
To now, I think no, I think no. But at the beginning of 20th century, the Korea has applied this technology in practice.
Okay.
Yeah, I think that's all.
We have a hand raised, but I cannot read the name because it's in Chinese character. So I will make this person a presenter so that you can call out. Yeah.
Sorry, I cannot see all
Can you hear me?
the participants. Please?
Can you hear me?
Yes.
Thank you for Doctor to introduce the content. And I have a question. Just you have answered that the price is $0.4 per ton for dyeing water. Am I right?
Yes.
And 0.4 or 0.6 to $0.8 per ton for what water? Sorry, I missed that.
Pharmaceutical.
Pharmaceutical.
In hospital, pharmacy.
Okay. Okay. That's my question.
So any other questions from our participants?
Okay, if that okay, I will raise another question. How long does it take from, for example, if a facility decide to use this technology? Let's say I say, okay, I would like to use this technology in my company to what you call that? To manage the water from the dyeing, from the clothes industry. From the decision, construction, and to operational, how long will it take?
Okay. Usually for the establishment of the electron beam treatment unit, it just needs about half a year. For the electron beam technology unit. So for other treatment processes, I didn't know too much. But for the electron beam technology unit, we just need half a year about the construction and the这试运行怎么说来？我操
！Trial.
对 ，yeah. To try the electron beam equipment. Half a year.
Okay. Thank you.
Okay. I'm asking maybe for the last time if there is any questions. If not, Marina is an IAEA officer. Would you like to conclude or end today's webinar?
Yep. Thank you very much,
Marina.
Thank you very much, Zhao Jing, for moderating this session. Very interesting information, Dr. Wang, for sharing your expertise on the development of this technology. We really appreciate it. And from the IAEA side, so just good morning to everyone. So I'm from the Technical Cooperation Division for the Asian and Pacific region. In fact, we do have a few projects wanting to apply this technology in their country in the next cycle. So we are waiting for the approval for those projects in November next month by our IEA Board of Governors, and we look forward to learn more from Tsinghua University and to support our member states who has a project about the application of e-beam technology for treatment of wastewater. Thank you again, and I look forward to see you face to face in the future. And thank you to
Yes,
all the
thank you.
participants.
Thank you.
Thank you. Thank you.
Thank you for the great support from IAEA side. Okay, thank you, everyone. This is the end of today's webinar. If you have any questions, you can find us at the ANENT website. We have emails. You can also watch the webinar's video at the ANENT website in maybe a few days. Thank you very much.
Okay, thank you.
Bye-bye then.
Bye.
Bye-bye.